Hey kids, I'm Trasher. I'm a garbage truck.
Hello. Today I want to talk about garbage collection. If you have no idea what garbage collection is, I'm gonna run this quickly by you. Garbage collection is when the JavaScript engine that runs your code frees up memory for you automatically. In many lower level programming languages, you have more control of memory. This means that you might be able to say, reserve this part of memory for me. And also you might have to say, free up this part of memory for me. In JavaScript you don't do that. In JavaScript you're not concerned about how much size your things take up. This is handled for you automatically. Therefore, there is a routine that is called the garbage collection routine that is run to free up memory that you are not using. And there are a few rules with this that I'm gonna try to explain by running this reference baller function here. Here on line 11, we create the data with the create data function. This stores the data in memory. Now we have a reference count of 1, and the only reference to the data is via this let variable data reference. Here on line 13, we create a new object that references the first. This does not copy the data in memory, it just creates a reference to it. Now the reference count is 2. On line 17, we put the data in an array. This doesn't copy the data either, it just references it again, but this time from inside an array. Now the reference count is 3. Here on line 21, we are unsetting the data from the initial variable. Now the reference count is back to 2. Then we do the same thing on line 23, but for the object, which takes the reference count down to 1. And finally, the same thing but for the array. And now there is no more references. The reference count is 0. Now it is safe to overwrite the part of memory that held the data. And that is because it is now logically impossible for a code to reach it. And thus it can be safely reused. Now the memory that held the data is considered garbage, and the garbage collection can run and free it up.
I roll up, I roll down, I squash the garbage to the ground, oh yeah, that's me.
Here we have a very simple program. It is just a spinning square, and here we have a button that says conservative, and here we have a button that says wasteful. When I click conservative, I will do an operation on an amount of items that will not create a lot of garbage. When I press wasteful, I will do a similar operation that creates a lot of garbage. Let's take a look at the code for this. Firstly, we have the little square variable here, and we just simply take it from the DOM. So if we look at the index.html, we have just some CSS up here. Here we have the script that I run, and then we have 2 buttons, and here we have the spinner in the middle. And the spinner is this square here. And the rotate code is just simply a little function that sets the rotate property in CSS to the current time that we get from request animation frame. Then we have a little variable that says count. It currently says 10,000, and this will mean that my program will create 10,000 objects. Down here is where we actually create objects. So we put all the objects in this array that we name items. And then we create this object. So it's simple, plain JavaScript object with a counter property on that we set to 0. Before we continue, I just want to get everybody on board. So we're gonna log out the items and see how they look. Here we are in the console. You can see here that I have 10,000 items in an array. And each item is simply this. A thing worth noting is that even though these objects look the same, they are unique objects. So if I increase the counter on this object, it wouldn't increase in this one. So I have 10,000 items here, and then we have the 2 buttons. When I click the button that says conservative, I will run the for loop for each item and increase the counter property by 1. When I click the wasteful button, I will iterate over all items again, but I will create a brand new object that has the counter increased by 1. Let's see how this behaves. So I'm pressing conservative increment ran. I'm pressing wasteful increment ran. So far it looks like there's no difference. But let's change the amount of items. I think we can up this to 10 million. So now we have 10 million items. Now look what happens when I press wasteful. So the square stopped for almost a second. Look now what happens when I press conservative. Almost unnoticeable. The reason the square stopped is because only one thread in JavaScript can run at any given time. So the code that rotates this rectangle cannot run at the same time as the code that creates objects. So because this wasteful increment took so much time, the browser couldn't update the animation for the rectangle or the square. And you can actually see here, if we enable verbose logging, we will have a violation message here that when we click the button, it took 875 milliseconds. This log message you will see in Chrome if you perform too much work in between animations. As you can see here, while I click the wasteful button, it takes a long time to recreate these objects. And some of this time is also due to garbage collection. When I press the conservative button, we have a completely different speed here. It is almost instant. If we open up the performance tab here, we'll be able to get a clearer picture of what's going on. I'm going to lower the amount of objects to get a baseline measurement. So I'm going to set this to 0 actually. So you can see here, where we're not creating any objects, we still have some memory use here. You can also see that it increases steadily. This has to do with our update loop. So just to show this, I'm gonna disable the update loop here. And let's take another measurement. Now you can see that it's stable. Now when we have our baseline, I'm going to enable the update loop. And I'm gonna enable some items. Let's start with 100,000. And let's get another measurement. Now our heap goes between 4.4 and 12.8 megabytes. Let's take a measurement while we're pushing the wasteful button. These spikes is every time we push the button. And when it goes down here, that is a garbage collection run. I'm going to increase the amount of items here to make this a little bit more drastic. Let's go up to 10 million and then remove this log message. I'm going to clear this result. Now I'm going to start recording. And when I click this wasteful button now, we should see the square stop. And we should also see peaks in the memory usage and garbage collection. So here we can clearly see how our program has spiked. Our JS heap is now between 385 megabytes and 1.6 gigabytes. Up here, our program peaked at 1.6 gigabytes. And here we have a garbage collection run. Now let's clear this data. We take a measurement and we use the conservative version. As you can see here now, is that this ramps up slowly, but this is very, very slow. This is less than 1% increase, so this memory waste is not from a for loop. Here we have another little fun project. It is a green square circling around, and this project will create a reference to a big object when I click create reference, and will break a reference to a big object when I click clear reference. So in here, some CSS to set up the style, and then we have the buttons and the spinner. In main, I have a function that creates an array of a certain size, and it just creates an object with an index property in it. So we just basically just create some data that takes space. The create reference button runs create array and assigns the result to my reference, which is defined here. And the clear reference button, it says my reference to undefined. Let's see how this works. I'm going to start the profiler, and then I'm going to click create reference. Do you see that the square stopped for a bit? Now I'm going to clear the reference. And that happened at approximately 12 seconds. Now I'm going to stop. As you can see here, when we created a reference, the memory went up. But when we cleared it, it did not go down. This is because the garbage collection didn't run. You cannot tell the garbage collection to run. So when you break references, you're not explicitly saying collect memory. This is handled by the garbage collection engine. There is a button here to explicitly collect garbage. Let's try something else here. I'm going to refresh the page, and I'm going to create the reference. So now we have collected memory here. Let's try to collect garbage. Do you see that? The green square stopped rotating for a while. Garbage collection also stops the JavaScript computation. JavaScript is not executing while garbage collection is happening. Let's see that again. Let's try a third thing. I want to see the memory usage go up and down, and I want to trigger a garbage collection explicitly. So I'm starting the profiler, then I'm refreshing the browser. Now, creating the reference, and running the garbage collection. Did not work. We clear the reference, we run the garbage collection, and now we create the reference again. So now we should see a peak and a dip and another peak. And here it is.